Hello my dear students, in continuation of our previous year question series, today we will discuss some more questions from Neet previous year questions. The questions are from Neet 2021. Starting with our first question, the first question is from the topic dimension of class 11. The question says, if E and G respectively denote energy and gravitational constant, then what will be the value of E upon G? This simple question is regarding the dimension. We know E denotes energy and G denotes gravitational constant. Then what will be the dimension of E upon G? So simply the dimension of energy is ml square t raised to power minus 2, and the dimension for G is equal to m raised to power minus 1 l raised to power 3 t raised to power minus 2. By simply dividing the dimension, we get the answer m raised to power 2, l raised to power minus 1 and t raised to power 2. That is our option number 2. This is simply the application of formulas of dimension. Moving to the next part, this question is from class 12, chapter number alternating current. Okay, the question says we are provided with a series RLC circuit. This is our inductor, this is our capacitor, and this is our resistor. The question says an inductor of inductance L, a capacitor of capacitance C, and the resistor of resistance R are connected in series. Actually, this is series RLC circuit, and the potential difference V is shown in the figure. Both the all the elements are in series and are connected across which supply? V volt supply. The potential difference across LCR. Now the question says the inductor is having potential difference of 40 volt, the capacitor is having a potential difference of 10 volt, and the resistor is having a potential difference of 40 volt. Okay, we have to calculate the amplitude of current flowing. No, because all the elements are in series, so in series condition we know the current is same, and the same value of current is 10 root 2 ampere. This is the current flowing in all the three elements. We have to calculate the impedance. As we all know, when all the three elements are connected in series, then the combined effect is known as impedance. Now in question I0 is given as 10 root 2 ampere. If I0 is given, we can calculate IRMS, root mean square value of current. IRMS is simply I0 upon root 2. So we get IRMS as 10 ampere. Okay. Now we have to calculate the value of impedance. Okay. For impedance, we can use the formula VRMS upon IRMS. IRMS we have taken as 10 ampere. Now VRMS can be calculated for RLC circuit as VRMS is equal to V under root VR square plus VL minus VC whole square. This is the voltage across resistor, this is voltage across inductor, and this is voltage across capacitor. Just putting the values, we get 50 volt. Now Z is equal to VRMS upon IRMS. VRMS is 50 volt and IRMS is 10 ampere. On dividing, we get 5 ampere, 5 ohm. The unit of Z is always in ohm. The unit of impedance is similar to unit of resistance, and capacitive and inductive reactance all are measured in ohm. Okay, moving to the next part. The next question is from your class 11 simple harmonic motion oscillations topic. Question says a body is executing simple harmonic motion with a frequency of SHM. SHM frequency that is equal to N. The frequency of its potential energy is. Now the frequency of SHM is given as N. We have to calculate the value of frequency of potential energy. Now if the object is having indulged in simple harmonic motion, we can say the difference displacement equation of SHM is given by x is equal to a sin omega t. Okay, A is amplitude, omega t. Now the value of omega is 2 pi n, because omega is actually angular frequency, that can be written as 2 pi n, where n is normal frequency. Now this is the general displacement equation of SHM. Now the potential energy relation for SHM is equal to half kx square. Now half kx square, we put the value of x as this. Okay, on just simply the relation of sin square theta is 1 minus cos 2 theta upon 2, we get this relation. Now in this we can say the frequency is n, and in this the frequency is 2n. So the frequency of potential energy comes out to be 2n. Okay, the similar question can be asked related to other energy concept, kinetic and total energy. We just have to put the values and calculate the result. Now moving to the next question. The next question is related to your magnetic field. Question says a thick current carrying cable of radius capital R carries a current I uniformly distributed across its cross section. The variation of magnetic field B due to cable with the distance R from the axis of the cable is represented by. We have to predict which relation between magnetic field distance is correct. Okay. Now, when the question is about the magnetic field and distance, the formula will be B in is equal to mu naught IR upon 2 pi R square. Okay. And B O means outside to mu naught I upon 2 pi R. On comparison, we can say the magnetic field increases with distance, reaches its maximum value. Okay. Because in this relation, we have relation with R as linear relation, B and small r, and after reaching maximum value it decreases. Okay. So the correct option is option number 4, which comes from these two relation, inside magnetic field and outside magnetic field. Now moving to the next part is related to nuclear binding energy. The question says a nuclear with mass number 240 breaks into two fragments, each of mass number 120, and binding energy per nucleon of unfragmented nuclei is 7.6 mega electron volt, while that of the other fragment is 8.5 mega electron volt. Now we have to calculate the total gain in the binding energy in the process. Okay. Now according to questions, an X element having mass number 240 splits into Y and Z of equal masses. 240 split into 120 and 120. Now the binding energy is given as X, Y, Z 7.6, 8.5 and 8.5. Gain in binding energy, we have to calculate the gain in binding energy, that can be simply calculated by binding energy of product minus binding energy of reactant. So binding energy of product comes out to be 120 into 8.5 into 2 minus binding energy of reactants is 240 into 10 raised to power into 7.6. The resultant is 216 mega electron volt. That is our option number 1. Okay. So we have just calculated the gap of binding energy. Okay. In next video we will discuss some more questions from the PYQs so that you can have the conceptual knowledge of the subject. Thank you.